Element 14 has a challenge where you have to fix household electronics. Just so happens that our household has an R2-D2. We're going to fix it because one of his lights is out and his panels aren't flipping correctly. Let's get to it. So what's going on here, Walnut?
Okay, so R2 has all these lights that blink. That one right there. It's not lighting most of the time, but then sometimes it just lights one color, magenta. It either lights magenta or nothing at all. But as you see on this diagram here, it should be red or blue, or scroll from red to blue. But you can tell right there that it looks magenta, full magenta. It's not scrolling or doing anything. And then poof, it just turns off on its own. So definitely not working right. So let's look down into the dome. And this right here, with the dome on the inside, you can see what is actually powering those lights. Now you saw in that one diagram that it's actually LEDs, blue and red. What controls the lights is actually a MAX7219 chip, which normally controls LED like clocks, the 8-segment clocks that they have out there.
Yeah.
And so what the guy did that put this circuit board together, he made them where they all chain together so it can light a bunch of light bulbs in there.
So what are the capacitors there for?
Those are capacitors on the power coming into the chip. For integrated circuits, you want very good, smooth power. This is powered by 5 volts, so that takes care of any dips or surges that may occur in the power supply. Although that very much could be part of the problem there. So one of the first things I'm going to do is give it an alternate power source. So I'm putting in just a wall wart, but it's only about a 1 amp output from the wall wart. And I plug everything in, and this is what I get. With everything plugged in with a 1 amp source, you notice the light's actually now working right. It's scrolling back and forth, but it's flickering real bad every time the servos kick.
Maybe the power supply is sort of going more towards the servos than the lights.
Yep, pulling a lot of load with those servos. So basically it's making the voltage dip, which when the voltage dips, that causes that whole other circuit to blink. So definitely we have a power supply issue, and I also went ahead and I powered the lights by themselves, and then I powered the servos by themselves, and they both independently worked fine. So here I looked at what drives the servos, and what I have is this Hololoo little brain here chip that allows me to program the chip to make servos stroke. And you notice on here they have up to 6 different servos can be powered through it. And they have an independent power to the board from the servos themselves. That way, the board can get good constant power, but the servos won't draw, kind of compete for amperage on the same circuit. Now, I have it all ran on the same circuit. Everything was on the same circuit here. Here you see the code that you program into that board. There's nothing wrong with that. I could re-upload it to make sure it didn't get scrambled. But pretty much what we're seeing here, when you go back and look at that board, how they separate the board's power from the servo's power to keep things working. Here we have all the servos. You see with the arrows there.
Why is there gold duct tape there?
Duct tape is an engineer's best friend. So now I'm going back to R2's body to see what I have here. And you see I have 5 volt. That's what's going up to that dome. And I do have, you saw on that one sticker, a 12 volt rail, which isn't reading 12 volts.
It's very small.
Yeah, it's very small. Basically, it's nothing. That's a 0. Since now we know I need to separate the lights from the servos, the integrated circuits from the servos, I'm going to use that 12 volt. As soon as I figure out why it's not coming up top, I'm going to use it as a second independent, dedicated power source for the servos. Now here's the motherboard for R2. At the bottom there is the main bus coming in. 12 volts are coming in from basically batteries that are used like for trolling motors in a boat. And from that I regulate down to 5 volts and 6.5 volts. And I go through a fuse block before I go out to the various devices. That way I have protection. Now, because I have no 12 volts up top, what do you think has probably happened?
A fuse might have blown.
Yep, that is it. that's why I put the fuse block there, is that way if any time a power line hit something, it would just blow the fuse and not start smoking cables, with just melting insulation off of cables. So I pulled the 12-volt fuse. It didn't look blown, actually, when you looked at it, but you see there I have an open circuit, so it definitely blew. So I changed it out, and now I got 12 volts back up on top, ready to be used to power things inside the dome. That's a circuit of its own. There's the 12 volts. Confirm that it was there. Now, what if I stuck that 12 volts onto my 5-volt integrated circuits?
Well, would you be able to regulate it down? Or?
Yeah, that's what I'd have to do, is regulate it down. So I just got a little voltage regulator. I didn't use resistors because that would be a waste of electricity. I got a little switching regulator. Since I didn't have any larger wire, I wanted to go ahead and beef up the wire, so I just twisted 2 small wires together. You can do that.
Yeah.
You can just, 2 wires added together is like one big wire. And also, by twisting it in that manner there, it made it real flexible, and they didn't come boinging apart or anything like that. And there we go. There's all the panels flipping. This is him. He's kind of booting up. He goes through the wave and different things in the program. And then you see the lights have come on. And they are working fine and no longer erratic. Doing their scroll thing. It's hard to tell from this video.
If integrated circuits are erratic, it could be because of noise in the power supply. It could also be because of a bad ground, but that wasn't what happened with R2. If there is no power, be sure to check for a short circuit or a blown fuse. But be sure to check for a short circuit first, because it can smoke a chip. If you have devices that draw a lot of current, their load could dip the power supply. This dip in the supply's voltage can make the ICs go bonkers. In our case, it was R2's dome servos. Make sure your cable is a big enough size to deliver the amps you'll need. What we did is braid 2 cables together in order to handle the amps. You should always stabilize your voltage regulators using capacitors. Also, put them around the IC power pins. Thanks for watching. Please like and subscribe.